The transfection consists of the introduction of external genetic material in eukaryotic cells by means of plasmid, viral vectors, microinjection, liposuction, where the genetic material is mixed in a lysosome which is absorbed by the cells, or other tools for the transfer. The term transfection for non-viral methods is used in the reference to mammalian cells, while the term transformation is preferred to describe non-viral transfer of genetic material in bacterial and non-animal eukaryotic, such as fungal, algae, or plants. The transfection of animal cells is generally carried out by opening transient pores or holes in the plasma membrane of the cells by electroporation to allow the passage of the genetic material. In addition to electroporation, other techniques can be used to effect transfection, such as ribose transformation or sonoporation. Before choosing a transformation method, it is necessary to consider the quality of the sample, since in case it is contaminated with phenols, ethanol, or detergents, it can damage the structure of the membrane and inhibit cell growth. Also, should look for the length of the plasmid to be between 2.9 and 12 kilobases to increase the probability of transformation. Similarly, it is essential to have strong cells, so it is recommended that the cells is in exponential phase, planted just a few hours before initiation the pressure. Thus, it is necessary to give the cells a recovery time in a nutrient-rich medium, such as the soak medium, and avoid subjecting them to a broad temperature change so that they can survive the process.
In this practice, we were able to transform the bacteria both chemical and by means of electricity. The cells could not be visualized well since they were uncountable due to the poor showing of the samples. Besides, the antibiotic use was not adequate conditions. On the other side, in the box that showed us was able to see the difference between the two colonies, showing that the blue colonies were in a small proportion between the white, showed that the transformation was correct. Another data to consider is the proper handling of the moment of making the transformations, because the competent electricians did not explode, so that means the management of the two trims was correct.
Transformation. This methodology is based on taking advantage of the composition of the cell membrane, which has lipid molecules whose phosphates were negatively charged. Within the membrane, there are quite long adhesion zones to allow the passage of molecules such as DNA, but the negative charge of the DNA phosphate are repelled by the phosphates of the lipids. It is necessary to use a salt to neutralize love. The most commonly used salts are calcium, rubidium, magnesium, potassium, and sodium. In addition to neutralizing the load of the lipids, a decreasing temperature is made to stabilize the membrane, and then a thermal shock is applied, raising the temperature to 42, which modifies the permeability of the membrane and allows the DNA to pass through it. Electroporation, it consists of applying an electric pulse for a short period of time that alters the conductivity and permeability of the membrane. It is an ionic physical process that requires a high resistance, cell suspension, and low conductivity to ensure the insertion of DNA and the bacteria do not die. This method is preferred over chemical transformation because higher transformation efficiencies are obtained for when it is used. Plasmid, ligate cDNA, and even genomic DNA. In addition, it allows to use very little amount of DNA. A requirement of the method is to have a pure DNA without salts, as well as to ensure that the culture bacteria have been desalinated, otherwise the salt would conduct electricity. The tension would be higher for the cells and they would die.
Well, in our conclusions for our transformation practice by chemical transformation and electroporation, we don't obtain efficiencies because we couldn't count the colonies of our culture. Probably we let them grow too much time, or the volume has to be diluted more. But some of the critical difference between one another is that once you use poles for increase the permeability of the membrane and let the molecules pass through, and the other one use salts and other components for giving the same effect, this permeability and pass of molecules. Finally, we have to consider some critical parts for the transformation or electroporation of the cells. In the case of the chemical transformation, one of the critical steps was the thermal shock, and consider the salts for the transformation and the addition of the salts. And in the case of the electroporation, it was critical the use of a correct program on the pulse, times, voltage, as well as avoiding adding salts to the sample that is going to be analyzed to avoid explosions of the cells.